The Rockies are the largest group of mountains in North America. They stretch over 1,000 miles, from British Columbia to New Mexico.
Most of the exposed rocks are sedimentary, meaning they were formed by water and underwater.
One of the most beautiful locations to see the Rockies is Rocky Mountain National Park in central Colorado.
Secular scientists believe these mountains were formed over tens of millions of years through slow and gradual tectonic processes.
They use continental drift as a mechanism for mountain building. Yet, this idea was originally proposed by a Christian geologist in 1859, where he suggested the continents came to their current position in less than a year during the global flood, and didn't take millions of years. Current Christian geologists have further research on this idea and now call it catastrophic plate tectonics. Then, there are other slow-forming geologic features. These features are related to the Rockies formation and erosion, examples being the Great Sand Dunes and Devil's Tower.
The Bible indicates that our Earth is only about 6,000 years old. What is the real story of when and how these mountains were formed and eroded?
What evidence suggests these mountains could have formed and eroded during the catastrophic events of the flood?
We'll find out all this and more next on Awesome Science.
Awesome Science takes you on a field trip to some of the most amazing geologic and historic sites around the world, where we use the Bible as our history guidebook to interpret what we see, that the Bible can be trusted, and empirical science falls in line with the biblical account of creation, the fall, and the flood. Science, it's awesome! In the state of Colorado, just west of Fort Collins, is the entrance to Rocky Mountain National Park.
The park was established in 1915 by President Woodrow Wilson.
It covers an area of 415 square miles, with many stunning vistas. From valleys to high peaks, the elevation changes from 4,000 to over 12,000 feet. It's a great place to get out and enjoy nature. There are over 300 miles of hiking trails, plus 150 lakes and 450 miles of streams.
Everywhere you look, there are amazing views. The park has 72 peaks that tower over 12,000 feet.
The park represents the best of all parts of the Rockies. Deep valleys, high peaks, rough terrain, and lots of wildlife. There are many stops along the highway for views of wild animals, opportunities to see elk and deer. Coming here is a real treat.
Mountains are found on every continent. How do they form? There are actually several ways mountains are built.
The first way is mountains can be formed by folded layers. The layers are pushed together on each end and begin to fold. The layers will rise and fall, twisting in the process.
Examples of folded mountains are found in the Rockies, Alps, Himalayas, and Appalachians.
Another kind is called domed mountains. This happens when pressures below the Earth's surface push up layers, and then the layers get bent. The Black Hills of South Dakota are an example of domed mountains. Then there are fault block mountains. This happens when layers shift up or down. Like a knife went through the layers and cut them up, so they shift vertically. The Grand Tetons in Wyoming are an example of fault block mountains.
Today, probably the most dramatic and visible formations are volcanic mountains.
These types of mountains form when molten lava comes up through the crust and pushes out onto the surface. They tend to be in linear chains across the Earth. They include the Cascades, Aleutians, and Hawaiian Islands, which are around the Pacific Rim.
Secular scientists believe the mountains we see today have risen over millions of years through slow and gradual processes.
But since the Bible indicates a much younger Earth, the processes for building the mountains, which we see today, would have happened much quicker in the past. There is a lot of evidence suggesting the flood was responsible for catastrophic processes. These processes would have formed most of the mountains in less than a year.
So we have mountains forming through upheaval, plus floodwaters carving new valleys and revealing more mountains.
Even during the several hundred years after the flood, as the Earth settled, there was still lots of geologic activity. Many of the volcanic mountains we see today were a part of that process of reaching geologic equilibrium. The Rockies only reach 13,000 to 14,000 feet, and they are made up of sedimentary layers. What's amazing about these mountains is they're full of marine fossils. Evolutionists presumed these fossils developed in a shallow sea covering this area millions of years ago. Below the sedimentary rocks, we find metamorphic rocks and granites.
Metamorphic rocks are sedimentary and volcanic rocks that have been changed by heat and pressure. The granites are assumed to be the basement rocks, formed over 1 billion years ago.
These three levels of granites, metamorphic, and sedimentary rocks are thought by secular scientists to be 3 generations of mountain building processes, the sedimentary being the youngest of these.
Many of the Rocky Mountains have been pushed up, faulted, and folded. How did this happen?
We now know the surface of the Earth is made up of various plates called tectonic plates. As far as we know, Earth is the only planet in the solar system with plates like these. The plates move. Currently, the rate of movement is slow.
They can collide with each other, pushing up mountains. When one plate slides underneath another, it is called subduction.
We know Mount Everest in Asia, the tallest mountain in the world, continues to grow in height by 4 millimeters a year. This is because 2 plates are pushing into each other. The amazing part about Everest is the top layer is sedimentary and contains fossils, which means they were formed by water. Since sea level is where most water is now, Mount Everest has risen almost 30,000 feet at some point in the past. Most of the floor of the Pacific Ocean is known as the Pacific Plate. North America is known as the North American Plate, and South America is known as the South American Plate. The western edges of North and South America are at the edges of those plates, while the east sides of those plates go all the way to the Mid-Atlantic Ridge.
It is thought by secular geologists that North America was much flatter many millions of years ago than it is now. Placid seas came and went, laying down many layers of sediments.
Then, some unknown geologic process began pushing the Pacific Plate down below the North American Plate. The Pacific Plate dragged down the western edge of the North American Plate and began to push up the North American Plate near its western side. This caused mountains to be pushed up, supposedly forming the Rockies over tens of millions of years. This upward pressure also allowed molten rock to rise from deep in the earth, causing some volcanic activity on the surface. As the sedimentary layers on top got pushed up, they were partially eroded to expose the metamorphic and granite rocks beneath, leaving tilted sedimentary layers flanking them.
All of these geologic processes supposedly happened over tens of millions of years.
Secular scientists believe that mountain building is an ongoing process, mountains being destroyed and rebuilt over and over again.
For the most part, creation scientists don't disagree with secular scientists about the mechanism for creating the Rockies, but they believe geologic processes happened much faster in the past.
Back in 1859, French geographer and scientist Antonio Snyder Pellegrini proposed that rapid horizontal divergence of the crustal plates occurred during the flood of Noah's day, and then slowed down.
This basically means tectonic plates began moving very quickly, initiating the geologic processes to start the global flood. During the 1-year period of the flood, they continued to move, going underneath each other or colliding. This caused the mountains to rise quickly and the floodwaters to eventually move off the continents.
He developed this idea after looking at how some of the Earth's continents seemed to match together. It appeared as if they were once connected. He proposed the Earth's tectonic plates were rapidly ripped apart and sprinted catastrophically to their current positions in less than a year.
Before this time, most geologists believed the Earth's plates were horizontally fixed. Pellegrini, a creationist, thought differently and furthered science as a result.
Later, secular geologists adopted this idea of diverging crustal plates. However, due to their worldview of long ages, they developed the idea of slow continental drift. Some would say the amazing ideas of a creation geologist were hijacked by secular scientists to prove long ages. This is an effort to use creation geologists' discoveries against them.
Unfortunately, slow continental drift has become the predominant theory among secular geologists.
In the 1990s, several creation geologists adopted Pellegrini's idea for quick movement of the Earth's plates during the flood. They furthered his research and called it Catastrophic Plate Tectonics, or CPT.
As it was examined in more detail, CPT appears capable of explaining a wide variety of data which slow tectonic theories are incapable of explaining.
In a pre-flood Earth, the Earth was differentiated into core, mantle, and crust. The crust was separated horizontally into large, stable blocks of rock above the waters, formed during the creation week. These types of rocks are mainly granites and metamorphic. The ocean floor was primarily made of mafic basalt, which is denser than granite. In CPT, the flood was started as slabs of ocean floor broke loose and subducted along thousands of miles of pre-flood continental margins. The pre-flood supercontinent also broke up into fragments called plates. This all led to the plates moving at feet per second, and mantle convection bringing up massive amounts of heat from the interior of the Earth.
The mantle convection affected the Earth's core, which induced rapid reversals of the Earth's magnetic field.
From near the core mantle boundary, large plumes of molten rock rose to erupt as vast volcanic outpourings called flood basalts. Rising basalt lavas from the upper mantle also rapidly filled the long linear ruptures in the seafloor, pushing the old seafloor aside. Rapidly, the continental fragments were horizontally displaced, pushing the plates. This rapid rising of basalt magma with steam came into contact with the ocean water and jettisoned ocean water with steam high into the atmosphere, where it condensed, creating intense global rain. The new warm ocean floor rose quickly as the new, less dense magma that had produced it poured out from the mantle. This caused sea level to rise so that the ocean water swept up onto and across the continents.
Now, the pushed aside denser, cold pre-flood ocean floor, as it subducted, started bending and upwarping.
Fast-moving ocean water facilitated the transport of sediments onto the continental margins. Large earthquakes induced tidal waves, with ocean-to-land movement further transporting sediments into the continental interiors.
This resulted in sedimentary rock layers covering regions and even entire continents that were eventually covered in thick and uniform layers of sediment.
This is very prevalent in the western United States, such as in the Southwest and the Rockies. Erosion of these sediment layers can be seen at places such as the Grand Canyon in northern Arizona and Zion Canyon in Utah. When the pre-flood, cold, dense ocean floor subducted under the moving continents and plunged into the mantle, it also tried to drag the continental edges with it.
But there was a problem. Further inland from its edge, the North American plate began to arch upwards, and thus the Rocky Mountains started to develop very quickly. There was some faulting as well as upwarping.
During this time, cracking in the crust also occurred, and large amounts of magma poured out onto the continents through volcanoes.
Because the subducting pre-flood ocean floor slab sank below Creation Week rocks foundational to the North American plate, these got pushed up too, examples being the granites and metamorphic rocks.
When all the cold, dense, pre-flood oceanic floor had been replaced with new, warm, less dense, less subductible oceanic crust, catastrophic plate motion slowed down and eventually stopped. The continental margin stopped getting dragged down by the subducting slab, so it bobbed back up again. The Rockies thus rose higher. This new ocean floor increased in density as it cooled. It then began sinking, producing deeper ocean basins. As the mountains were rising on the continents, the ocean basins were sinking, and the floodwaters receded quickly. It caused sheet and channelized erosion, planing off thousands of feet of sedimentary layers. Much of the continental shelves today are comprised of these eroded materials.
Even after the floodwaters drained into the ocean basins, there was a substantial period of gravitational readjustment, where local to regional catastrophes with intense earthquake and volcanic activity were common.
Post-flood sedimentation did continue, and was rapid at times, but was mainly contained to small basins on the continents. Huge geologic activity in the oceans during the flood would have heated up the water worldwide. This resulted in a significantly warmer climate just after the flood. Large storms dumped huge amounts of rain and snow on the continents, causing heavy erosion and the quick development of the Ice Age towards the poles.
CPT simply takes the secular continental drift idea and puts it in the context of the flood, which lasted only a year. The Rockies formed quickly during this time.
Even after the flood, they would have experienced more change, but not as dramatic, as the Earth settled and erosion continued.
Some creation scientists argue that recent earthquakes and geologic activity is still the settling down of the Earth from the events of the flood.
CPT is a great model for explaining much of the geology we observe around the world today. Based on Pellegrini's observations, the CPT model is actually older and more accurate than the secular model of slow continental drift.
When you take the biblical record as true history, it makes much better sense of what we find in the evidence. Science, it's awesome.
Back in 1785, James Hutton proposed that the Earth was immensely old. Before that, many scientists believed the Earth was young, using the Bible as their guide. Today, most geologists take Hutton's view for granted and accept that the continents formed at least 2.5 billion years ago.
Once you take a closer look, many geological processes indicate the continents are much younger.
One such process which indicates a younger Earth is the process of erosion. You can measure the rate of erosion across the world. Water is the main culprit. With some parts of the world getting more rain than others, the rate of erosion can vary drastically across the globe. Using current rates, the average height reduction for all the continents is about 2.4 inches per 1,000 years. In the 2.5 billion years of supposed Earth's continental history, 93 miles of continent would have eroded, which defies common sense on a planet where the highest mountains are only a few miles above sea level. At the current average rate, North America would have been leveled in less than 10 million years.
Either the average rate of erosion was much smaller in the past, the Earth just isn't that old, or the rate of erosion was much greater in the past, and the Earth is as young as the Bible indicates, only 6,000 years.
To make matters worse, mountainous regions with their steep slopes and deep valleys erode fastest, at an average of 39 inches in reduction every 1,000 years. Some mountains in Papua New Guinea have been measured to erode at 750 inches per 1,000 years. There is also evidence that the Earth was much more temperate in the past. Places that are now deserts, like the Sahara, were once very wet. In addition, an abundance of evidence in the fossil record shows a much wetter climate in the past.
So, if the Earth were even hundreds of millions of years old, the mountains should not exist.
Secular scientists say the process of erosion and mountain building is ongoing, so that as the mountains are eroded, they continue to uplift and build. So, the effect of erosion is not as noticeable.
Yes, uplift is occurring right now, but there is a major problem with this option. If current erosion rates are used, we should not find any old sediments in the mountain areas. Yet, we find sediments from all ages, preserved even on the highest peaks, such as Mount Everest.
Some have also suggested human activity, such as farming and dams, have increased the rate of erosion in recent history. Scientists have figured human activity can increase the erosion rate 2 to 2.5 times. But to solve the glaring problem of erosion over long ages and the erosion rate being less in the past, man's effect would need to have been several hundred times greater to make this argument valid.
But if we take the Bible literally, asserting that there was a worldwide flood, which happened in a year, then the rates of erosion would have been off the charts and match much what we find around the world.
The Bible says, by day 150, the entire earth was covered in water. In fact, the Bible states the highest peak from the earth before the flood was covered by over 23 feet of water. God's promise of destruction of man and animals was complete. Only those on the ark could have survived. Because many of the mountains today show evidence of rising quickly during the flood, the mountains before the flood were probably much smaller and hard to compare to what we see today.
Some also question how the entire Earth could have been covered by water. But if every continent was laid flat and the ocean basins were filled in so that everything was level, there was enough water to cover the entire Earth up to 1.7 miles. That's about 9,000 feet.
Psalm 104 verse 8 tells us that during the flood, the mountains rose and the ocean basins sank. As already discussed, catastrophic plate tectonics would have quickly pushed up mountains and eroded them quickly. Giant sheets of sediments, thousands of feet thick, were eroded in just days to months as the floodwaters retreated. We're here at 12,000 feet, one of the high points of the Rockies. See how flat it is out behind me? It's called a planation surface. The only thing that could have formed it is the flood. A planation surface happens when a giant sheet of water flowing quickly, spanning over many miles, will erode off entire sheets of sediments.
The retreating floodwaters would have planed or sheared off many top layers of sediment as the mountains rose, leaving behind a level and smooth surface.
Planation surfaces are seen around the world. When they happen at the tops of mountains, it can be very confusing to scientists who believe in slow and gradual processes, because they only result from quick, catastrophic processes. Eventually, the sheet erosion turned into channelized erosion, carving out valleys, canyons, and cutting through mountains very quickly.
The amount of water and erosion during the flood has never been seen again because God promised He would never send another global flood.
After the flood, the oceans were very warm due to volcanic activity and ejection of subterranean water, mentioned in the Bible as the fountains of the great deep. These warm oceans would have caused massive precipitation across the continents, making the rate of erosion much greater than it is today. This is exactly what we see in geology and the fossil record. This massive precipitation would have also brought on an ice age in a matter of a few hundred years. At the end of the ice age, the melting ice caused large regional floods, such as the Missoula flood in the Pacific Northwest. These floods would have eroded the landscape even further. After the ice age, the oceans would have cooled to close their present temperature, and the massive storms would have stopped. Eventually, an equilibrium in weather patterns would have brought erosion rates down to what we see today. The rate of erosion was not smaller in the past, but much, much larger.
When you include the level of erosion during and after the global flood, you can easily show billions of years of erosion in just a few thousand years. The Bible can be trusted as Earth's history book.
I'm here on the highest and largest dunes in North America, and yet we're in the middle of the Rocky Mountains. How did they get here? The dunes at Great Sand Dunes National Park in Colorado rise about 750 feet from the floor of the San Luis Valley and cover about 19,000 acres.
To the evolutionary timescale, these sand dunes are very young because they were supposed to have started forming only 440,000 years ago.
The Great Sand Dunes is at 8,200 feet above sea level. It is unusual to find sand dunes this high in the mountains. It is believed these dunes were formed from the sand and soil deposits of the Rio Grande and its tributaries flowing through the San Luis Valley. Over the ages, westerly winds picked up sand particles from the river floodplain. As the wind lost power before crossing the Sangre de Cristo Range, the sand was deposited on the east edge of the valley.
This process continues today, and the dunes are still growing, slowly.
Sand is usually made of small particles. The sand grains vary in their composition, but they are mostly from mineral quartz. Coastal sand dunes usually come from rivers emptying into oceans, where the wind picks up small particles and deposits them on the shore.
Instead of studying the sand dunes, let's go play in them. Wow, that's amazing.
These coastal dunes tend to have more minerals than mountain dunes, like here at the Great Sand Dunes. We know these dunes here in Colorado are post-flood because we know the Rockies were formed at the end stages of the flood, so they are less than 4,300 years old, not 440,000 years old.
We also know that sand dunes accumulate during times of climate change.
Not long after the flood, the Ice Age developed. At the end of the Ice Age, there was a drier period where wind-blown silt was carried across the continents. We find these deposits all around the world. During this time, several areas of the world were covered in sand, which had not seen sand before. For instance, we know the Sahara Desert used to be a lush area with hippos, giraffes, and habitations of man, but now is desolate and covered in sand.
Other areas, such as Nebraska, have large areas of sand dunes covered by grass. We also see coastlines around the world covered with sand and dunes.
The rate at which areas like the Sahara and Nebraska were covered in sand are thought to have taken hundreds of thousands of years, like here at the Great Sand Dunes. But given the right conditions after the flood, these vast areas of dunes could have developed quickly in just a few hundred years. Hiking the dunes here reminds us that the Earth went through a lot of adjustments after the flood, where climates changed and finally equalized to the climate zones we have today. If you visit the park and want to hike the dunes, be sure to wear closed footwear. The daylight sand temperature can reach 140 degrees and can burn your bare feet. The park is a great place to see something different in the Rockies. As the Rockies were rising quickly at the end stages of the flood, Huge sheets of water were running across the continents, and thousands of feet of top sediment layers were being eroded.
One clue for this massive erosion is found just east of the Rockies.
This here in northeastern Wyoming is Devil's Tower. It truly is a testament to the receding floodwaters' power. Rising almost 1,300 feet above the Belle Fourche River, Devil's Tower is enjoyed by thousands of visitors every year. Its summit is at 5,114 feet above sea level. There are two theories on how it formed. One theory holds that Devil's Tower is a large mass of volcanic rock, which intruded through sedimentary rock beds, but didn't actually reach the surface. The other theory is that Devil's Tower is a volcanic plug, or the neck of an extinct volcano. Devil's Tower was declared a national monument in 1906 by President Theodore Roosevelt. Devil's Tower is made of spectacular vertical columns of igneous rock with 5 or 6 sides each. At the base, these columns are about 7 feet wide and decrease to 4 feet near the top. The columns are composed of rock containing fine-grained minerals, suggesting they formed quickly and solidified at a shallow level.
Evolutionary geologists interpret the evidence here as proof of millions of years of slow erosion.
The rocks surrounding the monument are mostly sedimentary, which, according to secular scientists, were laid down by shallow seas 225 to 195 million years ago. Supposedly, around 40 million years ago, Devil's Tower formed around the same time that the Rockies were lifted up. Scientists have been able to determine the surrounding land was nearly 3,000 feet higher than it is today. Then, this half-mile of sediments was washed away over vast ages. But what does the evidence really show?
The flood could have provided the conditions to create the sedimentary layers above and below the monument, as well as created the volcanic activity and erosion of the layers, all within less than 4,350 years ago.
During the flood, the Earth's crust was changing dramatically as it shifted and contorted under the waters. Thousands of layers of sediment were laid down on the continents in a matter of weeks. The shifting plates would have broken open cracks in the crust, allowing large amounts of magma to push towards the surface.
In the case of Devil's Tower, the magma never reached the surface because of the floodwaters and soft sediments above. The magma would have cooled quickly.
As the Rockies were being pushed up near the end stages of the flood, large sheet erosion began planing off thousands of feet of sediments, exposing Devil's Tower, and the water would have begun channelizing, cutting the valley of the Belle Fourche River.
The biggest challenge to saying that Devil's Tower formed and eroded over long ages is that wonderful thing we call the rate of erosion.
We can observe and measure over the last 100 years how quickly the columns of the tower have eroded and fallen away. When we measure this rate, we can estimate how long it would take for the tower to totally erode away. Based on these rates, Devil's Tower should have been leveled long ago, according to secular theories. The fact that it's still here shows that it's only a few thousand years old. If we use the biblical timescale, everything begins to fit into place.
Rocky Mountain National Park is a great place to learn how the flood provided the right conditions to form mountains quickly around the world.
Other geologic features, such as Devil's Tower and the Great Sand Dunes, show quick formation and erosion due to the effects of the floodwaters and the climate changes after the Ice Age, also caused by the flood.
Erosion rates also show that our Earth is not billions of years old, but only thousands, especially when we include the erosional mechanisms caused by the global flood.
As you can tell by now, the flood had a major impact on the Earth we see today. The Bible says the flood was God's judgment on sin and rebellion back in the days of Noah.
With everything happening in our world today, and where man is headed, God promises another judgment on man's rebellion and sin, this time by fire. He loves his creation, but can't let it go on the way it is, towards destruction.
But he promises, if we repent of our sin and turn to his Son, Jesus Christ, and trust in his death on the cross as the payment for our sin, then God will forgive us, and we will walk with him forever in a new heaven and new earth.
If you have not done so already, we encourage you to repent of your sin and turn to Jesus Christ today.
Thank you for watching this episode of Awesome Science. And remember, science, it's awesome.